Greetings everyone. In this podcast I'm going to briefly describe what the coefficient of friction is and what is its use. So looking at the friction lab where we were sliding various objects across different surfaces, we noticed that as we changed the weight of those objects that the frictional force that the scale read increased proportionally. And we looked at this was true for both the force of static friction and the force of kinetic friction. So to take it a step further, imagine that we had a 4 Newton block. Okay, 4 Newton block. So normally I have the force of gravity is balanced out with the normal force. Okay, force normal, force of gravity. Let's say these are both 4 newtons. And then we have our pull, and that's going to be balanced with our force of friction. So if I were to push down on the table and I were to pull this again, I'd notice that that frictional force, or the amount that I had to pull, would actually go up. So if I were to do that, and I look at my object here, I'm not changing the mass of the block. It's still the same block. I'm not changing the weight of the block. It's still a 4 Newton block. But I am, when I start to push on it, I am adding another downward force, which means the table which is supporting it has to push back harder. So when I look at the force diagram afterwards, the normal force actually is going to go up to some value. It's going to have to match with my force of gravity and the force of push. So my normal force will increase. So for our experiment, we could really say that because the forces were balanced in ours, we could say that that weight was actually talking about the normal force. And we're going to say the normal force, and we're going to use that instead because it's going to get us more mileage. It's going to be more useful for us in more circumstances. So this gives us a new situation where we have this frictional force, okay, the force of friction, and it was equal to some constant value, some number. I'm just going to make up one, 0.25. And if I look at the slope of this graph, it's newtons over newtons is my unit. So the units cancel, it's unitless. So I have this number here, and then I'm multiplying by my x, which is the normal force. I'm just going to put a big N for normal force, or Fn, whichever one you like. So here's the equation. Now it was a little bit different. Notice that the force of static friction was steeper than the force of kinetic friction. It's always going to be greater for static. But looking at this here, this equation would be different. We would get different values for the slope every different surface combination that we would use. We could look up and we could solve for a variety of different surface combinations. So this is our frictional force. This is our normal force. And then this one in the center is what we call the coefficient of friction. It's this unitless constant that applies to a situation where we're looking at frictional forces between two surfaces. And this is going to be shown by the symbol, Greek symbol mu. Mu. That's how we're going to notice that. So there's two types of mu. I'm going to go ahead and go to the next slide here. So here's some common coefficients of friction between different materials. Mu sub s stands for static friction. Mu sub k stands for the coefficient of kinetic friction. So these are experimentally defined quantities, just like we figured it out, experimentally determined. They describe the amount of friction between two surfaces. Smaller the value, that means there's less friction, and the greater the value means there is more friction or it's more sticky. So you can just take a look at this table. And looking back at that equation, the force of friction is equal to that coefficient of friction times the normal force. Remember, frictional is a result of two things. Atoms scrunching from the normal force, and then atoms are going to be grinding. So if I look at the coefficient of friction, it's showing between those two surfaces what is the potential to have those different surfaces to have atoms grinding. And then the normal force tells me how scrunched they are together. And we get those combined, and there's more normal force, or there's more attractions between the surfaces, or there's more rough edges. There's going to be more friction because of that greater coefficient of friction. We look at rubber down here at the bottom. It has a super high coefficient of friction, very sticky. So it really has a lot of friction between that one. So this is a coefficient of friction. You can use this, our final two forms of the equation. I'll go back here in a second. So our final two forms of the equation, force of friction static is equal to coefficient of static friction times the normal force. Or, if we're talking about kinetic friction, exact same, except we're talking about the kinetic coefficient of friction. So those are two equations. All you have to remember is that friction is fun, because that little mu looks like a U. Oh, and the one other thing that you can do with this this equation is, if you wanted to, you could rearrange it to solve for the normal for the coefficient of friction. So I could rearrange both of those and have the coefficient of friction is going to be equal to the force of friction divided by the normal force. And I could do that for either one of those. If we had to, we could actually solve for the force of the coefficient of friction for any surface that we wanted to. Alright, I hope this video was helpful. Have a great day.